Alaikum assalam wa rahmatullahi wa barakatuh. Hello guys, we are going to talk about naming ionic compounds. Naming ionic compounds. And let's start with this video that explains how to name, just to break through how to name ionic compound. Let's go through it. I want to enlarge this one. Cation or cation. This one for metals. All metals tend to lose electrons. So group 1A will lose, group 2A will lose 2 electrons, 3A will lose 3 electrons and turn into positive ions. Positive 1 for group 1A, positive 2 for group 2A, positive 3 for group 3A, and so on.
Mister, you are not sharing the screen.
Oh, I'm not showing the screen. I'm sorry. We have started from the beginning. Okay. So let's start from the beginning. That's it.
Let's get some practice now thinking about how ions typically form, how they might form compounds, and how we name those compounds. So let's start with something in the first column. This first column is often known as, so let's start with potassium. K is the symbol for potassium. Now things in group 1 here, one way to think about it is their outermost shell has 1 electron in it. So they wouldn't mind losing that electron. So when they ionize, they tend to lose an electron and become a cation, a positive ion. And so let's look at a situation where I have some potassium that has been ionized. And I could write it just like this. We've seen that in previous videos. And we can refer to this just as a potassium ion. We could refer to this as potassium 1 plus. We could refer this.
Mister, can you please raise the volume? I can't hear it.
Now let's go on to the other side of the periodic table, things that would really love to grab an electron. So things in a group in the halides, which is this column right over here. So these are the halides. They have 7 electrons in their outermost shell. They would love to have 8. So they tend to be really good at grabbing electrons. And so let's say we're dealing with chlorine.
So the group 1A tend to lose 1 electron like potassium and turn it into positive ion, cation. And here the group halides or group 7A or group 17 tend to gain 1 electron, so they will have the outermost shell completed with electrons. So they would love to have 1 electron, to gain 1 electron, and turn into negative ion or anion.
And chlorine is able to ionize, so it's able to grab an electron. When chlorine grabs an electron, it will be a negatively charged ion. So you could write it as chlorine 1 minus. But the way that we generally refer to an anion, a negatively charged ion, instead of just calling this the chlorine anion, we would call this chloride. So this we refer to as chloride.
I said previously to name the anions or negative ions, we replace the last syllabus of the main word and add the suffix IDE. We have a table for that. If you bear with me, this is a table. Control C, let me take it and put it here. That's the table. Fluorine, fluoride becomes IDE. We mean we deleted INE and we add IDE. Chlorine, we deleted INE and we add IDE, the suffix IDE. Bromine or bromine, we add the suffix, we delete INE and we add the suffix IDE. Iodine, iodide. Oxygen, oxygen, we deleted this one, all of this syllabus, and we have oxide. Sulfur, sulfur, we deleted this last syllabus and we add IDE. IDE. Okay, guys. Nitrogen, nitrogen. We add nitrogen. So nitride, IDE. Phosphorus, we add phosphide, IDE. So that's how to name anions. This is the element name, this is the ion name. We delete the last syllabus and we add the suffix IDE. The suffix IDE is added. Like this one, IDE, IDE. This is the charge of the ion, -1, -1. You'll find oxide, -2, sulfide, -2, nitride, -3, phosphide, -3. So this table, you'll find it in your book and you have to save it. It's too important to save it. Let's continue.
Now, as you can imagine, with potassium having a +1 charge or 1+ charge, and this having a negative charge, they're going to be attracted to each other. And they can actually...
Just 1 minute. That's not increasing.
form an ionic compound. And the ionic compound they would form, we would write as, you'd write your positive ion first, and then you would write your negative ion.
Or writing the formula, even naming or writing the formula, we start with the positive part of the compound, or even molecule in the covalent molecules that we will come to it later. You have to start with more positive part of the compound. So we'll start in typing potassium first because potassium is positive, and end up with chloride in the end because it's negative.
And this right over here would be described as potassium chloride. Let me write that down.
Chloride.
Potassium chloride. Now you might be saying, well, let me rewrite the whole thing. So you know the chloride part, you say, okay, this is going to be an anion because instead of writing chlorine, which is the name of this element, I wrote this IDE at the end to say, hey, this is an anion. So I know that this is the chlorine anion. This is chloride. Why didn't I do something similar for potassium? Well, the way the convention works is if someone says potassium chloride, you know you're dealing with an ionic compound. And if the chlorine has a -1 charge, an ionic compound, the whole thing is going to be neutral. So if this one over here is 1-, then you know this over here, since they're 1 for 1, this is going to be 1+. So you know that you're dealing with a potassium cation and you could say a chloride ion or a chlorine anion.
He's explaining why we didn't name potassium like we add to the anion IDE. Why we didn't make something similar to potassium? He's asking this question, and the answer is that we know already that chloride has a -1. So for sure, potassium will has a +1 without changing the name because this is ionic compound and the whole compound is neutral. So we know that chloride is -1. So for sure, potassium will be +1 without changing the name itself of potassium. So forever, whatever, we start with the name of metal element, or the positive part of the compound as it is. We type it as the same type of element. We didn't change the name of the positive ion, cation. Cation name is the same like the original name of the element. That's because we already changed the name of an ion. We don't need to change the name of potassium ion because by knowing this is ion, for sure this would be an ion, an cation or a cation. Do you understand, guys? So there is no need to change the name of the positive part. It will be written, the positive ion will be written as the name of the original element without any change. We only change one, and by changing one and gathering it or joining it to the other part, for sure we will know that this is not the original atom, but it's the ion, because the whole compound is neutral. So this must be a positive one because chloride is negative one. Okay.
You could refer to it other ways, various ways, but this is potassium chloride. You have a positively charged potassium and you have a negatively charged chlorine, which we would call a chloride. In the next few videos, I'll do many more examples of this, and ones that'll be a little bit more complicated.
So that was a beginning to name ionic compound. From this compound gathered between metals, ionic positive ion from metals and negative ion from non-metal. The metal will be on the left of the periodic table, non-metals will be on the right of the periodic table. Metals will have a positive ion, non-metals will have a negative ion. The name of the non-metals is changed by adding the suffix IDE. The name of the positive ion is not changing. That's because it's defined by the name of the negative ion in the ionic compound. So we can start with this one. We have more other rules. You start by typing the name of potassium first. Come back here a little bit. I don't know what's not working, but whatever. You start with in the naming on typing of the formula or even the name of the compound with the positive part first. So I will start with potassium. After this, I'll end up with chloride. Okay, let's say another video about this one, but it will be extended video. That one. We will not listen to it, all of it, but we will listen to.
Okay, let's talk about how to deal with this worksheet here about how ionic naming rules work. So we'll talk about this. I'm not going to read out all the answers. I'm just going to talk about this to make sure you're listening. The first one, which type of elements bind in order to make ionic formulas? That is metals and non-metals. Remember, metals are anything on the...
It's talking about what makes ionic compounds. Okay. Ionic compounds formed between metals and non-metals. Metal to the left and non-metals to the right.
The left side of the staircase that separates the metals and non-metals. Non-metals are over here on the right. Metals are over here on the left. All right, so explain how to find the formula. If you have an element, you need to figure out its charge. Here I'm being easy on you and giving you the charge already done. If you don't know the charge, like if it doesn't tell you, you have to figure out this is +1, +2, +3.
He's telling you the charge. How I can figure out the charge of the ion that I have. Group 1A has a charge of +1 because they lose 1 electron and they have +1, except for hydrogen. Hydrogen is non-metal. Group 2A is +2 because they lose 2. Group 3, like boron and aluminum, they are positive and they lose 3 electrons. They are +3. So boron, aluminum, +3. Lithium, sodium, potassium, rubidium, cesium, +1. Beryllium, magnesium, calcium, strontium, barium, rubidium, all of this, radium, all of these are +2. Here, transition element may have more than one valence number or oxidation number. We will see this later. But for metals, group 1A, 2A, and 3A, they have fixed number or fixed oxidation number. Group 1A has +1, 2A, except for hydrogen, it's non-metal. Group 2A is +2, group 3A is +3. If we come to the non-metals, the halides, group 17 or 7A, they want to gain 1 electron, so they are -1. Fluorine, it will be fluoride, chlorine, chloride, bromine, bromide, iodine, iodide, and so on. All of this will gain 1, so they will be -1. Oxygen, sulfur, and all this group, all of them want to have 2 electrons to have similar configuration like the next or preceding or the successive noble gas. Oxygen will need to gain 2 electrons to have electron configuration similar to helium. And sulfur needs to gain 2 electrons to have electron configuration similar to argon, and so on. Nitrogen will have -3 because it will gain 3. It has in the outermost 5, it needs to gain 3. When it gains 3, nitrogen will be nitride, as we see previously, and will be similar to neon. Phosphorus, it will gain 3 because in the outermost it has 5, so it will gain 3 electrons to have 8, and then it will have electron configuration like the next noble gas, which is argon, and so on. So non-metals will have negative metals will have positive 1A, positive 1, positive 2 for group 2A, positive 3 for boron and aluminum, negative 1 for halides, negative 2 for oxygen and sulfur, negative 3 for nitrogen and phosphorus. Carbon is 4. It could be, it always share. Most of the time it share, but if it makes an ionic compound, it will be positive, negative 4. But most of the time it makes a covalent bond, not a ionic bond. So we have the atoms or elements that will make ionic bond. Non-metals are the most famous: nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, bromine, iodine. These are non-metals that you will use, you will see it. And the metals would be lithium, sodium, calcium, rubidium, cesium, francium, maybe beryllium, magnesium, calcium, strontium, barium, rubidium, or radium. You will find this one is one positive one, and this group is positive 2. You will find boron and aluminum. Those are the all metals, and those are the all non-metals that you will find them in the ionic compound. You have to save their names, yes. You have to save their symbols, yes. You have to know the name and symbol. Boron has the symbol B. Beryllium has the symbol BE. Magnesium, Mg. You have to save that. Calcium, Ca, C capital and A small. All the time, the first letter is capital, the second is small. Aluminum, Al. Oxygen, O. Fluorine, F. Chlorine, Cl. Bromine, Br. Sulfur, S. Phosphorus, B, P. Okay, and so on. Potassium, K. You have to know the name and the symbol. To name ionic compound, you have to know the name and symbol. That's very important.
3, -3, -2, -1, and 0. Anyway, if once you figure out the charge of an element, remember how you switch the charges. That means bring this 3 down here.
And I've explained that previously. If you want to name, I'll write the chemical formula of aluminum sulfide. Let's start with this one. So we started with naming the how to name the anions, how to name the metals itself. Let's come here and add another page, and I'll start with two opposite processes. Okay. And the first one, I'll give you the name, and then you write the formula, and then I think that I explained that before. After this, I will give you the formula, and then you will write the name. Let's start with the first one. I will start with magnesium oxide. Magnesium oxide. Sorry for handwriting, guys. Magnesium has a symbol Mg, M capital G. So you type, this is the positive part, this is the negative part. Magnesium has the symbol Mg, small g, M capital. And oxide from oxygen, it has the symbol O. The oxidation number, magnesium exists in the group 2. If we come here, let's come this, yes. That's magnesium. Magnesium in group 2A, so it will lose 2. So magnesium will have the oxidation number 2. I will write here 2. And the oxidation number for without any sign. And the oxidation number for oxygen is 2. And then I make the cross sign like this. Like this. So magnesium will take, Mg will take 2. And oxygen will take 2. And the formula, chemical formula, anything that be cancelled out, I have to cancel out. I have to put it in the simplest form. So we have 2 here and 2 here. So this can be cancelled out. This 2 can be cancelled with this 2. So we will have the formula Mg of magnesium oxide, Mg small O capital for oxygen. Magnesium oxide. This is the way how to name an ionic compound, or any compound, by the way, but mainly ionic compound, starting from the name itself. Start with the name and end up with chemical formula. The other one, I'll give you a chemical formula of ionic compound, and you have to give me the name. I'll start, for example, with I would say aluminum chloride. Aluminum chloride has a chemical formula Al, aluminum AlCl3. Sorry. That's aluminum chloride. So we know that we always start with the positive ion. You know that previously I have told you that when we type the formula or even the name, we start with the positive part. So this is aluminum, the positive ion or cation. So aluminum we have to write it here, it will be aluminum. Aluminum. And this is chlorine, so I will name it as a negative ion, not as an atom. And the chlorine, we change the name from chlorine to chloride. So it will be what? Aluminum chloride. Let me put it in a different name. Aluminum chloride. So that is the first or the simplest form of ionic compound. We can give you another one of ionic compound like this. I will write the chemical formula of the compound first, then we'll find the name. It would be NaOH. This is new one. There is something new in this compound. That OH here is called polyatomic ion. This is called polyatomic ion. This one. And it acts as a negative ion, like Cl minus, for example. OH, we don't deal with it as oxygen and hydrogen. No, we deal with it as one single ion. One single ion. We call it polyatomic ion. Polyatomic ion. It reacts in the chemical reaction, and those chemical reaction as a single ion. We have a table for it here. So this is the first table. I ask you to save it. And the second table was for the polyatomic ions. Before I come to this one, yes, that's it. This is called polyatomic ions. I will put it here for you, another one, so you can understand what I'm talking about. So this polyatomic ion, what does it mean? This is a group of atoms that is covalently bonded. They are covalently bonded. I will explain the details later. But when they get into chemical reaction, they react as a single ion. Let's take hydroxide, for example. OH, O is covalently bonded to hydrogen, but the sign on OH overall sign on the molecule OH is negative. So this one is reacting as a single ion and it has a -1 sign. So when I deal with it, I will give you oxidation number 2,1. Ammonium consists of one nitrogen atom covalently linked to 4 hydrogen atoms. I will explain this in detail later. But this 4 hydrogen and 1 nitrogen, which means 5 atoms, react in chemical reaction as a single ion and has a charge of +1. So the oxidation number is also 1. We write the oxidation number we write this one without when we type the name, we don't type positive or negative. You type it right now, no problem. But when you type the name, you don't need positive or negative. Nitrate, this group of atoms of nitrogen and oxygen, and they have sign of -1, and so on. So we call this polyatomic ion. They enter the reaction as a single atom or a single ion. So let's come back here. Let's start typing. Na is a symbol of sodium. That's why I told you you have to save the symbols and names. Na is sodium, so I have to write here sodium. And OH from polyatomic, this is polyatomic ion, and it is called hydroxide. You have to save the name of. So you have to save the formula and the charge and the name of each one of them. You have a lot of tables to save them here. Okay, guys? Again, you will save the formula, the charge for each one, and the name, how it's written. Hydroxide. So we'll come here. OH has oxidation number -1. We don't care about oxidation right now. We care about what? It's OH, it's called hydroxide. So the ionic compound is called sodium hydroxide. So, in naming ionic compounds, I could give you the name itself and ask you to give me the formula. And to do that, you have to know the number one, the symbol for each element, and the oxidation number for each one of them. And I tell you the famous one, group 1A, 2A, 3A, and group 7A, and 6A, and 5A. The famous ones that I told you. What would you save exactly? This one. You will save that. You will save lithium, sodium, potassium. Okay, all of these are positive one. Beryllium, magnesium, calcium. You have to save this too. And you have to save boron and aluminum, positive 3. And nitrogen, oxygen, nitrogen, phosphorus, negative 3. This is positive 3 and this is negative 3. Oxygen, sulfur, positive 2, negative 2. Fluorine, chlorine, bromine, iodide, all of them are negative 1. These are the most famous atoms or elements that you will meet them in naming ionic compound, so you have to save them. If something is new to you, you will come back here to the periodic table and figure out what is the symbol or the name of a specific element if you are looking for someone. Okay, guys? طيب. Let's take another example, then we'll go back to the slide because we'll stop here. I'll go to the slides after this. Here we'll start with name and end up with formula. I will start with the name, which is, let's give it the name, for example, potassium, ammonium chloride. I will write ammonium chloride. That's ammonium here, ammonium chloride, double M. Again, ammonium is not a metal. It's a polyatomic ion that is positive. So that's why we type it in the first. Because it's positive, we'll type it in the first as you see, ammonium. It's not a metal, but it's a polyatomic ion. That's it. Polyatomic ions. One of them is ammonium, which has a positive ion. And this is the only one that has a positive, by the way. The only polyatomic ion that has a positive charge is ammonium. And the only one that's written in the beginning, like this one, ammonium chloride. So ammonium has the symbol what? NH4, as you see, NH4. All this is ammonium. And the chloride, C from chlorine, Cl. Ammonium has the symbol or has the oxidation number positive 1. So we type here 1 without the positive. And the chlorine has the symbol, has the oxidation number negative 1. We type 1 without the negative. And then we make cross. So it will be NH4Cl. This is the final name. NH4 4Cl. Okay, guys. This is the ammonium chloride. Let's give you an opposite one. I will not start with the name. I will start with formula, and I will write FeCl3. And here I'm giving you something new. In this example, I'm giving you something new here. FeCl3. Fe is a metal, but it's a transition metal. Let me show you. Fe is here, and cobalt and copper is here, nickel is here. All this are called transition metals, and they are metals, and they have more than oxidation number. For example, Fe, iron, has 2 oxidation number, positive 2, and sometimes it has positive 2, and sometimes it has positive 3. To name it here, I have to identify it, which one is written here. Okay? So I will write iron chloride. This is one. How to name this compound? FeCl3. How to name something like this? Let's go back to this one and show you something very important here. That's it. So in this table, you will find some metals, cations, that from the transition element and have more than 1 oxidation number. Copper, for example, has 1, and sometimes it has 2. Iron, sometimes it has 2, sometimes it has 3. Lead has 2 and has 4, and so on. You have to save this one. So this is some famous transition metals that have more than 1 oxidation number. When I'm going to name it, I have to put this in my mind and try to write the name of the ionic compound using the right name. So let's come back here and let's see what iron we have here. We have FeCl3. So this Fe is second or third? Anyone can tell me, guys? This is Fe second or third?
Third.
Third, that's true. Why?
Because he wrote number 3 beside chloride.
Bravo, bravo, Ali. So we have here, as you see, we have iron second and they have iron third. If we come here, you will find Cl. Cl is -1. You do it like this: -1 Cl. I will type it in blue. Chloride is -1. Multiply 3. We have 3 here. So this all of this part is -3. So Fe must be +3. Okay, guys? So I'm going to choose iron from here. Iron third. I will write this one. Iron third. I will type it like this. Iron. Okay, and I is capital. Iron. And 1, 2, 3, third. And here in brackets, do it the same in brackets like this. And then you write the name of anion, which is chloride. So you have to save the name and how to write the cations with more than 1 oxidation number, and you have to know how to find this oxidation number, as I did here. You divide the compound, ionic compound, find the negative part, and then find the positive part. What is the charge of the positive part? Then you type it here on the name. Okay, guys? So this is one table. You have to save it. This is the second table, polyatomic ions. You have to save it. And the third table, I didn't think that to bring it. I have to bring it to you, or I will show it to you here. I think that it's here. This one I show it to you. This one I show it to you. Yes, this one I show it to you. So we have this one, and this one too. Okay, and this one. So this one we take it, the ions, negative, name them, fluorine, fluoride, chlorine, chloride. Second table talking about the transition mix and oxidation, the oxidation number, each one they have more than one oxidation number. And after this, you will take this table, which is talking about polyatomic ions. So we have 4 tables that you have to talk about them. Let me give you a quick quiz about naming ionic compounds. Naming ionic compound. So I will start quiz with you directly right now. Start live quiz, classic, continue. So that's it. Quickly join, guys, to the quiz.
Sir, are you going to send the link?
I'll send the link. That's it. I've sent the link right now, and that's the code, the pin. Sorry, that's the pin. So use this one or this one to join quickly, guys. Quickly.